Hello everyone and welcome to this video. So in this video we will continue with our TFX pipeline, and the next component in our pipeline is the transform component. The transform component performs feature engineering on the data set, right? So let's see how this component is used. So I am in my notebook. So for the transform components, we are going to do feature engineering. So let's go to the statistics and then see what type of feature engineering we can do. So we have numerical features and then we have categorical features. Now the numeric features are not in the same range. So if you want to, in machine learning, you have to put all of them in the same range. So we are going to do very simple feature engineering. We are going to transform um, all the numeric features and then put them between a range of 0 and 1. And then we will one hot encode all the categorical features, right? So just these two simple transformations, that's what we are going to do. So let's look at how we can do that. And to do that, we would go here and write some model code, right? Now, the TFX transform component requires a transform file. So you write all your transformations in a transform file. So we are going to do that using the magic command write file, and we are going to specify the name of the file and then call it transform.py, right? And then, so whatever we write after these lines will be written into the transform.py file. So the first thing we are going to do is we're going to import TensorFlow as TF, and then we're going to import TensorFlow transform as TFT, right? And then we have to specify a list of all our numeric feature keys. So if you don't know what your numeric feature keys here is, your age, capital gain, capital loss, education, final weight, hours per week, excluding the label, right? So we are going to create a variable called numeric feature keys. Now if I just run this and then go here to transform.py, you can see that it has been written into our transform.py file, right? So numeric feature keys, the first is age. The second numeric feature key is capital gain. The next one is capital loss. And then we have education num. And then there is also final weight. And then there is the last one, which is hours per week. Hours per week. All right. So these are all the numeric feature keys. And then we also specify um, another variable, which will be our categorical feature keys, right? But I will call it vocab feature dictionary, right? And then for the vocab feature dictionary, we have to specify the number of unique, right? Um, like the unique vocabulary in each of the categorical features, right? So, for example, if you look at something like education, there is high school, some college, bachelor's, um, 11th, 10th grade, and stuff like that. So these are the unique values that exist. So we have to specify those values. So for education, it was 16 unique values. For marital status, it was 7. For native country, we had 41. For occupation, we had 15. For race, we had 5. For relationships, for relationship, we had 6. For sex, it was 2. And then we had one for work class, which is 9. So let me see if I spelled education, marital status, native country, occupation, race, relationship, sex, work class, right? And then we have to specify a variable, which is you see how it will be used later. So so um, out of vocabulary brackets, which is 2, and then label key, which is our label, right? Label, right? So the num out of vocab bucket is just to give it some flexibility. Let's say you're trying to use the model in a production environment, and then there is a feature or a unique value that is not in one of these. Let's say occupation comes and then there is pilot, but there was no pilot in your. Yeah, it would be able to do some transformation because your out of vocabulary bracket is larger than what you are using for your, yeah, something like that. Um, so even so we have our feature names or our feature keys. But when we are doing the transformation, I want a different name to apply to our transformed features, right? So that we can differentiate the non-transform features from the transform one. So I'm going to write a function that will rename all the transformed features, and then this will be key, and then I'll say key is equal to key dot. Now I don't like this hyphens in feature name, so I'm going to replace all my hyphens with underscores, right? So um, replace all hyphens with underscores, and then I'll return the key plus some string, right? So some string like xf, right? So if I see a name in the features that has xf, it means those are the transformed features. Now the transform file that we would feed to our transform TFX transform component. TFX transform component requires that the transform file contains a pre-processing function. So we are going to specify that pre-processing function, and then it takes inputs, right? And then it would return a dictionary of outputs, right? So I'm going to say for key, let me leave another space here. So I'm going to say for key in numeric feature keys, right? So we are going to scale all of them. So tft dot scale to 0, 1. So you can see there are a whole lot of other scales there that we can use. And then this will be inputs slash key, right? And then of course we have to transform the name So this will be transformed name, and then we have key, and then let's just reshape it into a one dimension, just in case. Reshape, scaled, right? So this is just by doing this, we have transformed all our numeric feature keys, and then let's transform our um, categorical features. So for key and vocab size in vocab feature dect dot items. So we have to compute and apply some vocabulary, which will give us some indices. And then after getting the indices, we one hot encode those indices. So basically that's how you do one hot encoding. You have to get some indices, and then you one hot encode whatever those indices are, right? So we have to get some indices. So we say tft dot compute and apply vocabulary. This will be inputs, and then depending on the key that we are looking at in our vocab feature dect, and then we specify our num out of vocab buckets is num out of vocab buckets, right? And then the next thing is we have to one hot encode. So tf dot one hot, right? And this will be our indices, all right? And then this is our vocab size plus the number of out of bracket vocabulary, right? And then after that, we just so I'm going to copy the outputs transform name also here, put it over here, and then this will be also tf.reshape, right? Here we are not reshaping scaled, we are reshaping one hot, right? And here is vocab size plus the num out of, yeah, so something like this, right? And then the next thing we have to do now is our transform also our outputs, right? Our label. So we say transformed name, which is label key. Let's cast our label to a float. So tf dot cast inputs label key, right? Tf dot float 32. And then after doing that, we return the outputs, right? So I'm going to save that, and I hope there is no obviously there might be some typing errors, but the pipeline would show us, so when we run it we would know. Now how do we use this component? So I'm just going to say transform component, right? So the transform component, so we say transform, so we say tfx dot component dot transform. The transform component takes the in examples, so examples, and that'll be example gen dot output examples. It takes also a schema, so we say schema, a schema gen, right, dot outputs schema, and then it takes in the model file that we just wrote. So that will be transform. Um, the model file we wrote was, I think, um, transform dot py. Yes, so transform dot py. So transform dot py, right? So this is how we, and then we don't forget we have to add this to the component. So transform, right? And it's as easy as this. We are done. So go ahead and then I'll run everything from um, the beginning again. So I would run this, right? We don't need to create our buckets. We can read a data file again if you want. We can write this if you want. We can create our pipeline. We can run our pipeline. And let me see. And then we can submit the pipeline to Vertex AI platform. All right, so the pipeline has been submitted. We go back to that. You can see that it is pending. So I'll pause this video. Um, Hopefully there will be no errors, but if there is an error, I'll come back to this video and then fix it. So as you can see, the first component has finished running, and then the second one is now running. So let's keep waiting. And as you can see, the example validator and the transform are running in parallel since the two components don't depend on each other. So let's see what happens. Yeah, you can see that the pipeline failed. So we can go to the view logs and then see what happened. So it's saying that the pre-processing function in transform.py was not found. And if you go up also, so here we have no such file or directory transform.py. The reason is this is running, all our jobs are running in containers, right? And so if we just say transform.py as I specified here, it's going to look in the container and then see whether the transform.py file exists in the container. So we have to put this transform.py in our storage bucket. So let's go to the cloud storage bucket, and then we have our salary pipeline. We have our data. Right. I'm just going to put that transform.py file over here. Right. So let me see. So you can upload that file over here. So after uploading the file, you can just click that file and then copy the location of that file and then go back into our and this, and then we're going to put that over here so that we specify the directory that the file is living, right? So hopefully this works. The only thing is that we have to run the whole pipeline again. Uh, yeah, I made another mistake. So because I placed the transform file in the same folder as the in the same bucket as the data. The CSV example gen also now says, hey, the transform file is not a CSV file. So yeah, let's go ahead and then fix that. So yeah, instead of create, I'm just going to create another folder and then call it models, right? And then I'm going to delete this, the transform.py models, and then I'm going to upload the transform .py file over here. So it has been uploaded. Let's see, models, transform.py, and then I'll just copy this bucket location, go up to here, the model file, paste that in there, and now let's run everything again. All right. So we don't need to run this. We run the create pipeline and then the run pipeline, and then we submit the job again, right? So let's see what happens this time. So there was an error, and I think some of you have already fixed this. So marital status was supposed to be a comma, not a dot. So usually when you are running this TFX pipeline, this is not the normal workflow that you would use. You would definitely run your pipeline locally on your computer, as I've already shown in your other videos, in my other videos, and then before you translate it to your Vertex AI pipeline. So some of these errors, you would catch them easily when you run them locally on your computer, right? It's just that because we are running this on, I don't want to go through the whole process again. So that's why we have so many errors now. So we will run this again, and then if there's another error, I would fix it and then show you what went wrong. And don't forget, because we fixed this error, we have to re-upload the transform file into the bucket. So go ahead and do that. And finally, all the components were able to finish running. So you have the transform. And the first time I think you run the pipeline, it takes a while, but subsequent runs, even if you make a mistake, has not doesn't take so much time, right? So finally, we have run all the components, and yeah. So the next component in our pipeline is our tuner. So with the tuner, we are going to create a model, deep learning model, and then tune the parameters of the model, and then we'll use those parameters to train the model and then we evaluate, and then we push the model to our bucket, and then we serve some requests. So we'll continue in our next videos, and if you have any um, problems, let me know in the comments, and keep watching.